So in this video we're going to look at the indeterminate form, infinity over infinity, and similarly to the previous video we're going to see that this form is meaningless in a sense. So if we look at each of these limits, we have the limit as x goes to infinity, and we have rational expressions where we have a numerator and the denominator that are polynomials. And if we think about this carefully, if we take the limit as x goes to infinity on just the numerator, this numerator is going to become infinitely large. This denominator, because of the x cubed term, is going to become infinitely large. And we're going to wind up with the form infinity over infinity as x goes to infinity or becomes infinitely large. And each of these will play out the same way. The highest degree term on each polynomial will dominate the behavior of the function, and 2x cubed becomes infinitely large and 3x cubed becomes infinitely large as x goes to infinity. X cubed becomes infinitely large and x squared becomes infinitely large as x becomes infinitely large. So each of these has the form as x goes to infinity, infinity over infinity. What we want to notice is that the limits are different even though the forms are the same. So what we learned in Calc 1 was that when we are taking a limit as x goes to infinity or negative infinity, if we have a rational expression with a polynomial numerator and a polynomial denominator, what we learned is that only the largest degree term in the numerator and the largest degree term in the denominator matter. So it's sufficient to look at the limit of x squared over x cubed if x is going to infinity. And as long as x isn't 0, which it won't be because x is going to infinity, this simplifies to the limit as x goes to infinity of 1 over x. And now we have a constant numerator with the denominator that's getting infinitely large, so 1 over something infinitely large is just going to be 0. Here, the limit that we have will simplify to the limit as x goes to infinity of 2x cubed, the largest degree term in the numerator, divided by the largest degree term in the denominator. And x cubed over x cubed is just going to equal 1, so this simplifies to 2/3. And this last one, the limit as x goes to infinity, we will simplify, this limit here will simplify to the limit of x cubed over x squared. The chump change isn't going to matter as x gets infinitely large. And x cubed divided by x squared is just going to be x as long as x isn't 0. And the limit as x becomes infinitely large of x is actually going to be infinity, so we have a limit that does not exist because infinity isn't a number. So the idea again is that the form infinity over infinity is meaningless in the sense that this form can play out as different limits. And so what we're going to do next then is develop a tool, L'Hopital's rule, for dealing with these types of indeterminate forms.